This episode of Troxel is supported by Avail. Content is more than Revit families. If it's digital, Avail can handle it. Learn more at getavail.com. Welcome to the Troxel Podcast. I'm Evan Troxel. This is the podcast where I have conversations with guests from the architectural community and beyond to talk about the coevolution of architecture and technology. In this episode, I welcome Professor Douglas Noble to the podcast. Doug is the Associate Dean for Academic Affairs at the University of Southern California, also known as USC, where he teaches building science and facades courses in the architecture department. In this episode, we discuss a student-led design, fabrication, and construction project that was recently installed in Joshua Tree National Park. We cover the entire process, including the design, the technology involved, collaboration with consultants, working with the thin shell concrete prefab team at Clark Pacific, logistics and transportation, and installation. This episode ticks all the boxes: architecture, students, technology, fabrication, and one of my all-time favorite national parks, where I've been rock climbing since the mid-90s. This was a fantastic conversation with Doug. Do me a favor and share this episode with your colleagues and leave a rating and review of Troxel on Apple Podcasts. By doing that, you can help support what I'm doing and broaden the reach of conversations like these in my attempt to elevate the industry using the magic of algorithms in the podcasting universe. And please don't forget to visit the sponsors who make this episode possible. So without further ado, I bring you my conversation with Douglas Noble, PhD, FAIA. Doug, welcome to the podcast. Great to have you.
Thank you very much. It is great to be here. Good to see you.
You too. I think the last time I saw you in person, we chatted a little bit about this, was at the Tom Kundig lecture at Cal Poly Pomona. You were on sabbatical, I believe. You were kind of trading places in the academic sphere between USC and Cal Poly for a little bit.
Right. We have several architecture schools here in Southern California, and sometimes when someone goes on sabbatical at one of the universities, then someone from another university can slip over and cover that class for a semester. I taught a facades class. It was really quite enjoyable. I'm also a Cal Poly Pomona alum, so I have another connection that makes me want to participate with them.
Well, that makes two of us. So, and that's why I was at that event as well. And it just luckily found out that Tom was speaking there, and it was a fantastic lecture. But I think that was the first time that was the second time we met in person. The other time was at the BIM Bop. I think it was the last in-person BIM Bop. I've been to a few of those, but I was speaking at that last one as one of the last Bops, and that was really fun. I miss those in person, but I also understand that now doing it online is just giving you a much larger audience and giving people the opportunity to show up that they normally would never be able to do.
The BIM Bops are spectacular. This year was the 16th. It was fully online. We hope to go back to at least a hybrid because while we are able to get a global audience, and there were it was a huge turnout. There's a lot to be said for talking face to face here on a nice campus in sunny Southern California. So the next one is monkeypox and Corona and everything else allowing. We will be hybrid and have an in-person.
Best of both worlds.
Yes.
Yeah. Right. Well, those have been amazing. And as a free resource to the community, I think it really speaks to the community that this podcast is aimed at, right? Which is kind of the intersection of architecture and technology and kind of watching how those things are evolving over time. And you guys fit so much content. You and Karen, we definitely shout out to Karen Kenzik also. When you put these events on, you get so much content in there. I mean, when it was in person, there were two separate tracks, and you could kind of pick one or the other depending on which session you wanted to jump into or out of to go visit the other one and go between the two lecture halls. And so now that it's online, you just have this continuous stream of information all day long, and then finish it up with these 5-minute presentations, which I think are a great way to cram even more in, but also focus the speakers on what's really important, the most important things to say.
Everybody says they love the bops at the end, right? The BIM bop really is 98% Karen Kenzik. I'm there to hand out name badges when we're in person and that kind of thing. And then when we do the licensing or facades events, then I'm the 98% and Karen hands out name badges. So a pretty impressive partnership.
That's great. And I think most people like the BIM bops just because Karen has always got the gavel ready to bop somebody.
She always verbally reminds them that she's ready to bop them. I have not seen her actually bop anybody. I think she'd like to, but I think she'd like to bop me primarily. So, well, I do enjoy her humor about you got to finish or you're going to get bopped.
You're going to get bopped. Yeah. Yeah. Well, you teach building science and facades at the University of Southern California at USC. And you also teach a national parks class. And one of the reasons I wanted to have you on is just because it seems like between the BIM bops, the building science, and the national parks class, you have been posting on this project on LinkedIn and I want you to introduce it because I have this kind of Italian pronunciation that I want to run by you. But go ahead and introduce this project. Like I said, it's kind of at the intersection of all of these things coming together.
That's exactly right. So the project is called the Carapace Pavilion. Carapace is a word that means that outer shell on a tortoise, right? A desert tortoise. And yes, the Italian pronunciation and even potentially Italian interpretation of the possible Latin meanings, we did think about that with Carapace. And so that is certainly. So the Carapace Pavilion was a project that started just about 4 years ago. And I'll give you the brief version of the history so we can get on. I think the technology is really the key here today. We've been working with the National Park Service out at Joshua Tree for well over a decade. We do hypothetical studies of potential projects that we know they're never going to build. Joshua Tree National Park is a wilderness park. They're not really in the business of making visitor centers and those kinds of things inside the park. They have 3 existing visitor centers, not much to speak of architecturally, plus a new sort of multi-agency center. But we have been doing studies, and the purpose was, from our point of view, giving architecture students a chance to work on a project in a very challenging location. Joshua Tree National Park has an extreme climate. It can be 110 degrees in the daytime, routinely. On that same day, it might freeze overnight. The project locations could be 10, 20, 30 miles away from anything. No water, no power, no waste, no help, no nothing. And it's going to be 110 degrees today. Let's get started. And so that challenge to the architecture students gets us going, right? And that's 4 inches of rainfall every year. That's you're going to have. There's no water source. What are you going to do? And that first thing I say, well, giant big roof will collect all the rain. And I say, well, you're stealing that from all the plants and animals that used to get it. Are you sure you want to do that? They say, well, we'll dig a well and we'll pump groundwater. I say, well, Palm Springs and other localities have already thought of that, and they're pumping it out for all kinds of reasons. The water table's falling, and the Joshua trees are dying. So, are you sure you want to do that? And pretty soon it's real challenging. So, we did hypothetical studies for the Park Service. After years, we decided we wanted to try to do something real, make a real thing. And Joshua Tree National Park doesn't make real things. They don't have architecture in the park, really. So, what can we make for them? And they came and said, well, if they thought about it for some time, and what they really could use that we could make for them would be trash cans. You know, those precast concrete trash cans.
Yeah,
and, right. We pretended to be earnestly enthusiastic and interested in this idea. And we came back with a counter offer. We said there actually is a building type in Joshua Tree National Park. It's those vault toilet buildings that are ubiquitous throughout national parks and state park systems. You've seen their little precast concrete boxes with a sloped roof, and they stick them in everywhere. They're precast concrete, kind of all look similar, although there's some adjustments. You have some of these things, and the ones you have at Joshua Tree don't look like they belong to Joshua Tree. How about if we reimagine what that thing might be like as though it fit in Joshua Tree National Park? And one of the tenets we have in the design studio that I teach is the project needs to clearly belong to a place. If your building that must belong to Joshua Tree National Park is found and it had wandered off someplace to another state, people should be able to look at that and say, uh-oh, that project is lost from Joshua Tree National Park. Let's get it back over there. And so we've been doing that for a long, long time. What can we do with these restroom buildings? So we elected a twin restroom, a paired restroom system. We're working with precast concrete, and we decided we would design and build a new one that looked like it belonged with those magical, almost sort of lunar or Mars-like environment, gigantic rock formations. What can we make that feels like it belongs here? So that's how it got started.
That's a great story. There's so many things that I want to just throw in here before we actually jump into the meat of this conversation. Number one is those toilet vaults that you're talking about. My favorite detail about those is in the formwork, they have made a special place for a sign that is on every single one of those that says, "Don't throw trash in the toilet."
Yes, they have that.
And I'm always like, yeah, I get it. And those things are awful. They smell awful. Obviously, they're remote, and they get a lot of visitors. But Joshua Tree is just a really special place. And to your point of the high deserts of California and the temperature swings and the lack of water. And I mean, Joshua Tree itself, I think, is at about 4,500 feet of elevation, which is kind of this perfect microclimate for the Joshua trees, which the park is named after. And obviously famous for a rock climbing destination. I've been out there over 100 times for rock climbing alone. And it's just one of those places that is really special. And to your point, it is interesting that the visitor center, even the main visitor center as you come in from the northwest entrance, is in the town of Joshua Tree. It is not at the park entrance, right? Really all there is up there is the check-in gate and some restrooms and a water fill station, and that's it. And so as soon as you leave the town of Joshua Tree, you are in the desert wilderness. And so one of the things that, as a rock climber being out there, it's kind of hard to find shade. And this idea of a pavilion, I haven't been to the site of the pavilion yet, and I can't wait to go do that. That's probably going to wait until the fall, though. It's going through a heat wave right now. But I can't wait to visit it because it's one of those things that it's like a welcome resource that you can provide, which is just shade, right? And there's other things that we'll get into that the pavilion does, I think, that are really interesting. But anyway, I just wanted to throw some of those things in there because it is a special place to me. And it was one of the reasons, it's just one of the reasons why I was interested in getting this story from you, because I think some of the other reasons are just how much storytelling you're doing with this small project. I think architects could really pay attention to this, as it's not just marketing, but it's where does the value of architecture come from? And the way that you're kind of telling these micro stories of different aspects of the pavilion that people may or may not notice, I think is just another fascinating thing that I really wanted to talk to you about today, along with the tech side of it.
Absolutely. Yes. Shade is a premium at Joshua Tree. Even though they're called trees, the Joshua trees technically aren't trees. And they're not known for shade. Sometimes you can find a rock to perch underneath a little bit, but it is
or a cave,
or something like a cave. There are some. I exaggerated earlier when I said there are no buildings out there. There actually are some. They're hidden. They have some surface buildings and things like that, and some staging places for when they, need to do road maintenance and those kinds of things. But they're not buildings that people see or visit. You wouldn't know they were there as a visitor to the national park. They're not public spaces in the park.
I think there's also some like a residence at Keys Ranch, just because those were things that were there before it was a national park. So yeah, there are a few, but they are hidden. Like you said, they're kind of camouflage. You can't see them, you can't find them. They're out of sight, out of mind, and it's really about the natural landscape more than anything.
That's what the Park Service is trying to get people to see, right? This is the point of the park is this magnificent and weird natural landscape. And so one of the rules in the design studio for the national parks is that any architecture that you do for a national park has to be worthy of America's best idea. It has to be national park quality building. It has to be truly powerful and not the most important thing at the location. The natural environment is the point.
Yeah,
right?
a lot of those buildings are kind of inside out, right? They're like pointing to things that, I'm just thinking of like the Grand Teton Visitor Center by Bowen Chwinski Jackson. They have these cues inside to tell you what you should be looking at that's outside of the building.
Exactly, and the one at Zion is spectacular. Now, people know some of the wonderful visitor centers that do draw attention to themselves, but in recent years, it's been more about it must truly be outstanding architecture,
right?
But not the thing that people drove to get to. They're not saying, I need to get up to, Olympic National Park because there's this great visitor center. Oh, going to Olympic National Park and look at this great visitor center. Let's check it out and then get out into the park.
Well, let's get into the tech side of things, because I think that, the student angle here is fantastic because it's a hands-on course. There was a ton of collaboration with different consultants as well as design, and then fabrication, logistics. There's so many aspects to this project that we can and should talk about. So where's the best place to begin?
I think maybe a general description of how the thing got started, and then you have to promise not to laugh at us when I say this was a 5-month project. It took just under 4 years to accomplish, and we can talk about why it did take so long. I think maybe a sort of a good general description. We knew we wanted to build something off-site. If you want to build in a national park, you don't want to have a construction yard, or you want to minimize it as much as possible. You can't have things parked all over the natural environment while you're making noise out there and those kinds of things. And so among the many rules is we had no construction site. We were asked to install the project start to finish in 1 day. We actually did it in, technically really about 5 hours. There was a little prep time. I'm not going to count that. Your listeners won't know anything about it, right? So it was a little bit of prep time. So absolute minimal impact on the site from a construction point of view. So we were off-site. We also promised the Park Service 100 years with no maintenance. So this is a project that has to be able to withstand extreme climate abuse. It's in the highest possible seismic location. If you know Joshua Tree, there are earthquake fault lines running all the way through it. It's actually technically adjacent to what others know, the San Andreas Fault, and our location, the Blue Line Cut and others. So it's a super high seismic location. It's also a native cultures sensitive location. The native cultures were living in the Joshua Tree National Park area for millennia, and not just a few of them. The climate conditions were a little different back then, and so it wasn't quite as dry and desert as it is now, although almost. But in many places throughout the park, you can find native cultures artifacts, and we wanted to make sure we did not disturb that either. So, and primarily this was an architecture school exercise. So we set out at every opportunity to make it educational and do the more challenging strategy rather than just doing a step to get it done. So that's part of what resulted in the 4-year thing. It was mostly, our doing, but I get to say things like government shutdown and pandemic as my excuses, but we can all know that, yeah, Doug, you said you built it off-site. What's the pandemic got to do with this? And it's, shh, don't tell people. I'm saying pandemic slowed us down. Pandemic did slow us down a little bit, but fundamentally we were slowed down because we kept making it more and more challenging. So there's tech throughout. There's technology in the materials, there's technology in the design process, there's technology in the fabrication strategies. We tried as much as we could to do things that would challenge the students. The project was nearly paperless throughout, design, fabrication, installation. We wanted to be paperless. I'd be lying if I said we were completely paperless, because there are times when you're sitting there and you sketch a thing for somebody sitting next to you. But fundamentally paperless, fundamentally 3D. We were designing in a 3D world, and we had to craft new software tools to be able to do that. In this case, it was really quite a challenging geometry. The 3D design geometry was fed to 3D milling tools to mill our foam out. It was never really 2D. I struggled to find things like a plan or a section or an elevation. They're sort of artificial, and the thing is so wildly curved.
Yeah, it's interesting to think of those kinds of diagrams that you've posted in your storytelling after the fact, only just to show how it frames a view or things like that, right? Like that's where this kind of 2D aspect is coming into it. I can totally see though, and we'll put links so everybody can see what we're talking about, because I think you know what it looks like. I know what it looks like. I'm sure very few of our listeners actually know what this looks like, but maybe you could just explain the form, what it actually looks like, and then we can kind of reverse engineer through the conversation of how it got to that point.
Excellent. So the project is about the size of what you normally see in the park as a twin restroom building. It is 42 feet long in its longest dimension, right at 12 feet wide. It is kind of like a tube, except it's double curved in all directions. So there's really no straight line on anything. The roof at 42 feet extends rather significantly beyond the walls and the foundation part of this tube geometry. The overhang is really quite impressive. At the bottom, at the base, it's only 12 feet long. So it's a 12-foot footprint, 12 by about 6 footprint on the ground, and it is 12 by 42 feet up at the roof. So it is this enormously long shade structure. We patterned it off the idea of a twin restroom, but the Park Service wanted us to build the shell part first separately so that they could see what this thing was, get it out in the landscape, learn about the materiality and the geometry before they subject people to using it as a restroom. So the first prototype, the one we built, is just a shade pavilion. It doesn't have the restroom facilities in it. It's open all the way through. But it's completely designed to be able to, in the next version, to put a partition in, the doors in, the vault pieces in, all those kinds of things to make it an appropriately designed restroom. We did all of the ADA geometries, so it could be. But this one is a shade pavilion. The project started out with the intention of using what we call regular concrete. In the precast world, they call it precast, because precast concrete people have other words for things that are not like regular precast concrete walls. And so we had a bunch of rules given to us. We had one area to work. We had a precast partner, Clark Pacific Precast, a big national company. Clark Pacific gave us a place to work and all kinds of support throughout. They were helping us and advising us throughout. But they gave us one place to work. And that one place to work was actually slightly smaller in length than the Carapace Pavilion itself. So we knew we had only one mold to cast panels into. But there's only room for one mold. So we had to craft a very clever mold that allowed for 3 different types of panels. The bottom curved panel for the foundation, 2 side panels, and then 2 roof panels to get the extension. And it has rotational symmetry like a propeller. So the 2 side panels are not a mirror of each other. They each have a twist and a curve that when you rotate around to the other side, it's the opposing twist and curve. We worked with Walter P. Moore engineers very, very closely. What a wonderful relationship. They were with us almost daily. So trying to work through the engineering aspects of this unique form. And within a few weeks, maybe 2 weeks at the start of the design studio, we knew we couldn't make it out of regular precast concrete. The loads were too high. The material was too heavy. They were telling us the dimensions. And so we went through many, many iterations before settling on a relatively new material in architecture called ultra high performance concrete, or UHPC. It's not that new. It's decades old. It's used in reinforcing bridges and other special conditions. It is extremely strong. It's a traditional precast, traditional concrete that we all know about might be measured in the 4,000 to 6,000 psi compressive strength. That's normal. 4,000 is sort of a normal number people use. Ultra high performance is much, much higher than that. And we engineered the Carapace at 17,000 psi.
Oh, wow. Okay.
We tested it, samples, at 25,800 psi. So the compressive capabilities of ultra high performance concrete are mind-numbingly high. And I'll give some examples to help people sort of visually grasp that here in a moment. The other characteristic of ultra high performance concrete is that it does not use traditional rebar. There's no rebar in the Carapace Pavilion. Instead, for the tensile characteristic, you mix in fibers. And there are different kinds of fibers, from glass fibers or steel fibers or stainless fibers and those kinds of things. And you just mix it into the mix. And the fibers are remarkably small. It's hard for people, less than an inch long. Hair-like or smaller. Incredibly small, but they're blended everywhere. And so all these billions, trillions, I tried to calculate one time and I couldn't do it. It's just an incredible number of these tiny little steel fibers that are everywhere in the mix. But it means we never had to make a double curved rebar cage in a wild geometry that dealt with all the little aperture holes that are throughout the project. So the materiality was a huge part of the design of the project. Traditional precast wall panels, in the regular sense, might be 4, 5, 6 inches thick. And you have to have concrete covering over the rebar, right? You know the diameter of the rebar, and then you do the little math work there to give you 1.5 inches or 2 inches of covering so that the water can't get into the rebar to rust it and spall it and do problems. So you end up with a 6-inch thick panel. The Carapace Pavilion is 2 inches thick in the narrow part. And part of that is it's really strong. Part of that is because of the steel fibers, it can pick up the tension. But part of it also is I don't need coverage for the water getting in and rusting the rebar. The water can't get in. And there's no rebar cage for it to get in and get after. So a kind of a marvelous material.
That's awesome. I love this whole conversation because it really brings together all of these elements that, this podcast is about the coevolution of architecture and technology. And I love thinking about this from the student's perspective and what students are getting exposed to early on in their career. You might actually be kind of spoiling a normal architectural career for them by exposing them to these all of these amazing things, because the level of collaboration that's going on between fabrication and construction and engineering and architecture and design, that's what every project actually does. But at this level where you're actually building the thing and fabricating it and going through the mold process, fabricating the molds, there's just so many levels to this. Was there a point at which did students actually get to experience the entire process, or were they some students in the early phases, some students at the later phase? I'm sure some of that changed, but is there anybody who got to experience the whole thing?
There are several that made it all the way through. We started out with a group of students who were in the beginning of their 4th year. And so the project turned out to be 4 years through installation. So many of them graduated halfway through. But a few of them went on to grad school and stayed in touch. There's one that went on to grad school at USC and sort of stayed with us. And then several of them became professionals in the local area, and I kept making them come back and work. So the original studio group, a standard studio group, eventually became something around 300 students participated in one way or another. And so, and hands-on, right? People are out there sanding, casting, making the mold, doing all those kinds of things. Early on, one of the real challenges was that this geometry is really impossible to draw or sketch. I made some humorous sketch attempts early on to try and get the idea of to the students. What are we really trying to do here? But double curve propeller rotational geometry. So we had a graduate student conduct a master's thesis on creating a software tool that would allow us to design the mold, cast the 5 wall panels in so that they could be all assembled together and have the fluid edges. When you see the project, you'll see that the walls come up and meet the roof in this wildly curving, twisting geometry, and it has to meet exactly along that smooth line, and they're going to be cast on opposite sides of the mold. So these geometries were really wild, and the tool was not created to tell us how to build one design. The software tool was created as a design tool, so students could use parametric strategies to adjust. There are dozens and dozens of variables about how the panels meet each other, the thickness of the panel, the length, where the openings or apertures are, and so it was a design support tool that then became a tool that fed the CNC. And the students did this, right? We have CNC milling on campus. The students got the machine, got the file, got the foam out, and we had to make 16 and a half of these big foam panels. Each one is maybe almost 3 feet wide and 8 feet long, that we assembled together on a plywood egg crate frame to make this very difficult double curve geometry. And then we had to seam them all together. So hundreds of students participated.
That's fantastic. Let's take a quick break to share more about our sponsors. You've already heard a lot about Avail as a longtime sponsor of the show, but wait, this is a new message for you, distinguished listener of the Troxel podcast. We can't talk about Avail's latest desktop release without talking dynamic paths. You know what I'm talking about. Yeah, of course you do. Dynamic paths allow BIM managers to store data in BIM 360, OneDrive, or any other cloud solution. In the latest version of Avail, they expand on location agnostic, making content easier and faster to find for the user. Imagine not having to worry if the content is on a local network drive or in the gazillion cloud storage locations. How is this even possible? Pure magic. It's the stuff of unicorns and rainbows, my friends. Let's keep this just between you and me. Here's some of the details. Following on the promise of being content agnostic, Avail now makes location complexity a thing of the past. Content is more than Revit. It ranges from Rhino to AutoCAD to Office documents. Well, this is next level. We're talking network locations. Have you ever seen one location where all the project content lives? Snap out of it. Of course you haven't. Content can live anywhere, from the local network to BIM 360 to OneDrive to any other cloud location. Why does this matter? Well, good thing there are no dumb questions, because the answer is that it frees up users to concentrate on design, which pays the bills, and getting content into a project, not managing technical issues around network drives and paths. Let's face it, they aren't that good at that anyway. Avail's mission is to make finding content simpler and easier. Like our favorite architect Louis Kahn once asked, "Data, where do you want to live?" I don't think he really asked that question, but Avail allows teams to, so let's just roll with it. And hold the phone. For those of you who know what this means, Avail also supports federated data requirements. Data can live where it needs and must live, allowing users secure and simple access to it. So, what's the takeaway? What's the big picture here? Settle down, I have it right here. Avail is a platform that connects all types of data from all types of locations, hiding complexity. Try it today. Go to getavail.com to learn more. And now let's get back to our conversation. I think I mentioned to you before, I did a project after Cal Poly, after I graduated, and it was like a weekend course with the topic was like FEMA disaster kiosks. And the area that we were designing for was Pasadena, like a bunch of unreinforced brick buildings. And so the idea was, what happens when the big one hits in Southern California? Well, downtown Pasadena, Old Town Pasadena falls down, right? What are we going to do about it? And so that was just kind of the overall design, the idea. And Steve Bedaines from Jersey Devil, University of Washington, came down and was part of the jury and the instructors, and along with some other Cal Poly instructors. And it was it was what you're talking about. It was a hands-on design build. We had to build the kiosks that we designed full scale. I mean, we're just talking about lumber, though. We're not talking about the things that you're talking about. And the reason I bring this up is just to contrast the evolution of design and technology in school. I mean, granted, this is a big project. The scope is big. The time frame is long, but compared to what I did, compared to what is available to students today, they're writing software to design these doubly curving, complex surfaces. You're working directly with engineers to what's possible, what are the constraints. A mutual friend of ours, Alvin Huang, he lectured in my class when I was teaching at Cal Poly, that he had this quote up from an engineer, and I'll paraphrase it because I don't remember it word for word, but it was, the best engineers want to solve the best problems. And I can imagine like working with Walter P. Moore on this kind of a design problem was really interesting for them. And it probably breathed extra life into that relationship that you were establishing with them on this process to solve a really interesting problem, right? They're not just calcing beams and columns, right? They're not just calcing the sheer value of this, panel. This is a complex surface. This is something that's going to be put in an iconic location. There's a lot of extra elements going on here that I think just paint a picture that's very different from my experience in school. And I'm just wondering if you could speak to this kind of, idea when it comes to what students have access to nowadays, and what that process for them was. Was that something that was interesting to them? Did they realize how cool this was, or was this just kind of like, yeah, this is normal now? I'm just wondering where we fall on that spectrum.
I think your point is really absolutely crucial. Years ago, perhaps when we were in school, the idea of a structural engineer as a consultant conjured up, Excel spreadsheets. We'll show you where the columns go. You just tell us how big, and we'll drop them in for you. The reality was never like that, right? Structural engineering, all consultant, is a partnership, and some are more partners than others. In this case, Walter P. Moore people, they were fully engaged in the process, fully engaged in the design from the very beginning, and by fully engaged, I mean over the top, right? We're saying things like, "Well, we'd like to be as thin as possible," and they're calculating it out and then coming back to us and saying, you said thin. How about if we try something like this? We'll make it even thinner.
Beating your expectations, right? That's just an amazing feeling to have when working with an engineer and a consultant, because that doesn't happen all the time. And when it does, it's like, really? Just everybody gets more excited and has more ownership of the project.
That's exactly. They're doing finite element analysis. We've got people from their LA office, their Texas office, and their New York office passing files around. This was pre-pandemic, so we weren't all Zoom wizards at the time, and we were doing the best we could with the sort of collaboration tools. And it was an amazing, how far can we push this? And we're going nuts here, right? Our instructors say, when you want to have an overhang, it's 2/3 on the columns and a 1/3 overhang. And we're going, well, actually, we're looking at a 12 foot on the bottom, 42 feet on the top. And oh, by the way, it's made out of concrete, and it's hanging way out over like that in a high seismic zone. Let's talk. And powerful stuff, right? Because we're using parametric systems to create the openings. People will see the Carapace has 198 holes in the roof, and none of them are the same. And they start out sort of larger and square at the very edge, and they morph to becoming circular in geometry, cylindrical in geometry, and smaller back to the center. And that's not just pretty. The bigger holes are out where the overhang is the farthest. We're reducing the weight. The larger holes are way out at the edge where the shade starts. So we're getting that light transition from lighter to darker from the very edge of the condition. And then the holes are positioned in a diagonal grid that allows the structure to go through. These days in architecture, people know more about the thing called a diagrid. They've seen it on the skins of buildings like the Gherkin in London. So the diagrid is a known thing. So what looks like cool holes casting light are actually doing a lot of things for us. We're dealing with weight management, structures management, right, all kinds of things. And then the fact that there are 198 of these things and they're no two alike is an additional interesting challenge.
Yeah. And so is there an appreciation from the student perspective of this kind of tech and this the level of collaboration and everything that's going on there? What are you seeing as an instructor and your long history at USC in teaching?
Students are really interesting. When we're in the middle of doing it, and I'm thinking, this is the most awesome thing I could even possibly imagine, they're all casual. Like, I've done that six times a day. But I think part of it is they don't know how far out we are. Right? I signed up for a studio. We're doing a studio, right? It's like, yes, but wow, we're doing something here. And then, and so you think, well, jaded kids these days, right? You hear, but the truth is, they were incredibly into it. We're getting emails and Slack channel stuff going in the middle of the night. People are doing the micro adjustments, and then when we install it, people crying. I mean, it is an amazing thing to go, wait, what did we just do here? Because I think all of us had doubts that we would get to the finish line, right? There's so much complexity. And so do they understand? We preach to them a little bit. One of my favorite quotes to remind them is the difference between sort of training and education. And I tell them the purpose of an architecture school is we're not here to train people to work for Frank Gehry. We're here to educate them to replace him. And so it's not about, let's just show you how AutoCAD or Revit or something works. You have to know the next thing. And are we really way out in front of the best of the best architects? Well, of course not, right? The best of the best are out there doing absolutely wonderful and marvelous things. On the other hand, we're doing wonderful and marvelous things as well. If I'm allowed, I'll tell you a fun story about being in the precast yard. We spent months on our little concrete casting deck in Fontana, Clark Pacific. I mean, months. I think they thought we were going to be there for 4 or 5 weeks. We were there for 3 years on their deck, maybe more than 3 years. And during that time, hundreds of students, lots of visitors, people coming out for tours, people coming to see what we're doing, touring the plant, seeing other things going on. And my fun story is these people came out, architects, professionals. What is ultra high performance? What is glass fiber reinforced concrete? Let's talk about all these kinds of things. And they're looking at our project and touching it and doing things. And I never said a word because I wasn't allowed to at the time. There was a project being constructed adjacent to ours in the yard, in the precast yard. Many projects while they're under construction are semi-secret. So you can't say over there, look at that, what's going on. The project being constructed right next to us was the new tower downtown by Frank Gehry. Right? It's being precast in the yard right there. And I've got hundreds of people coming out to see what I'm doing. And there's Frank Gehry's project sitting there. But here, let's take a look at what you're doing. Now, his project is really kind of cool, right? You've seen it with they move the openings around and so on, a really clever system of using the same mold over and over again. The building actually appears to have this rotational twist going through it. So actually, really cool stuff. But I didn't point that out. I was just sitting there going, they came out here to see my project. They're not here to see Frank Gehry over there doing his project. All due respect, Frank Gehry, if you hear this, great project. We weren't allowed to tell them what was going on. So that project is just finished. Is it called Grand Tower, the one right next to Disney Hall? Magnificent, wonderful thing. Fun to watch it going up. I live next door to it, which is kind of interesting
Well, you
accident.
got to watch
So
the whole thing then. That's
I was
fantastic.
watching them casting it, and then I would drive home from the casting yard and watch them lift the panels up into place.
Some of the storytelling that you've been doing about the pavilion has been really fun to watch and kind of reveal some of the hidden elements you in the pavilion. I would love it if you would just talk about some of those, because I think they add to the complexity of the project, and they're not things that are just obvious. When if anybody is able to go visit this, and I hope people are, these are the things now that I think this audience would be particularly interested in finding out about it, so that they would be clued into those things, because like there's no sign that explains all this stuff out there, right? So I would love it if you would maybe reveal what some of those things are. And obviously we'll link to your LinkedIn profile so that people can read through these and see the images and the diagrams that you've kind of prepared. But it would be fun to talk about them.
I'll describe a few. You can tell me when to stop. And there are also some that I have not yet described in social media. We have a open house event coming in the middle of December, and I hope I can reveal everything between now and then. But I think some of the things, for example, the Carapace Pavilion points true north. We had a lot of talk about what is north, right? There's magnetic north, which is off by 11.2 degrees. There is project north. There's map and Google north. There's solar north, which we've all grew up knowing you put a stick in the ground and at noon the shadow points north. Well, that's good enough if you're lost in the woods, and it's kind of a nice Boy Scout rule of thumb, but technically not true, right? Because time zones and where the sun is and all those kinds of things mean you can be off by almost an hour in either direction. Close enough. The stick in the ground at noon on your watch, head north. You got it. But it points true north. It points true north kind of by accident. The students spent literally hours framing two views out of the end of this tube. One is the long distance view to the mountains beyond, and a lone Joshua tree that's sort of set in the frame, and it has to fit in the frame of the opening as the tube has an opening and the overhang sticks out. And so from inside, you've got to frame that exactly. We used foam core cutouts that we would hold out at arm's length that had the best we could do of the geometry to be able to frame them. The other side points to a cluster of rocks that are right close by. So there's the long side view. That's Joshua Tree, the place. And here's the close sort of rock view.
Kind of the two elements of Joshua Tree that make it so iconic, right? Yeah.
So, and then when we did all that, after we had set it, we've got the stakes in and we're doing all the work, we're checking, and I have a compass, old Boy Scout guy, right? Always got that out. And I got out the compass and I showed everybody, look, we're about 11 degrees off of north on this project. That was pretty close. And sort of smiling, knowing full well that 11.2 degrees off is actually true north, magnetic north right now, declination at Joshua Tree. It was exactly pointing north, even though the compass wasn't showing that. Another thing we did, the roof tips have an angle to them on both ends. And so the north roof tip, the shadow being cast, points directly at the summer solstice sunrise. The south roof tip points directly at the winter solstice sunset. And that's an homage to Ralph Knowles. I don't know if you know Ralph Knowles. Ralph Knowles taught at USC for decades in the 1960s. He was, sometimes we call him the sun god. He was all about solar access, natural forces, natural rhythms, shadows, shadow movement, and those kinds of things. And so Ralph Knowles' ideas and thoughts are pervasive in the school. We work really hard to get people to understand time and motion, solar geometries, how the sun moves, what are these things going to be like. And so we wanted to make sure that we were doing things like that. We also know that people will come to the Park Service and you say, well, this thing points exactly at sunrise on June 21st, exactly where the sunrise is going to be. We know people will get excited about that. And then, of course, by accident, the installation day for the final project, when we were finally done, was June 20th. So the first full day that it was in place was the summer solstice. So, hooray, perfect. We got it. We got pictures of the shadow being cast and pointing off. There are more. I don't want to fill your whole time here with stories of all the little details of things, but there's a lot of interesting small things that people can come and look at.
I love it. I love it. These are perfect, and this kind of idea of further embedding this into the environment with elements like the ones you just talked about are not going to be obvious to a lot of people, but for the ones who are listening, for the ones who are reading your stories, and they're going to be the things that they look for when they're there. And I hope they actually take the time to visit those on those calendar days to have those experiences, right? Because it's that, I think, is further connecting it to the reality that it sits there.
Exactly. I have another one that's really quite enjoyable. I mentioned earlier we were talking that the Joshua Tree has a lot of native cultures influence, and the native cultures people still participate with the national park. Right? It's a major thing. And so, if you want to build something, if you actually want to install something in the park, you've got to do some work on native culture artifact surveys and all those kinds of things. And so we did a strategy to make sure we were not impacting native culture's artifacts without having to do a survey to find out what we found. Our strategy was very clever. We raised the ground level at the site by about 14 inches. Then we dug the foundation into that 14 inches. We weren't allowed to dig, right? There's no disturbing of the site. And then we used earth anchors, these things that are like giant tent pegs, screw anchors. They're used to hold giant radio antennas and things like that. We use earth anchors to hold the project down, which means effectively negligible impact on actually the site. And the project looks like it's completely embedded in part of the ground. If you go there now, you'll see this tube geometry is sunken into the ground, and the interior is the local earth, right? You're walking on a dirt floor right through the pavilion.
And it kind of hides the little part of the anchor that pops out, so you don't even see that it's there. And I think one of the things about this visually is it's kind of upside down, right? Like if it landed there on its own, you would expect it to be kind of flipped over from the direction that it is, because the overhang is the heavy part of the structure. You would think it would kind of roll into place and that would be the base. And so it is just kind of defying physics in the direction that it's doing that. And I'm glad you brought up the anchors, because I think people would be interested to see that. It is such an invisible feature that enables this to have the visual impact that it does. You know, this thing would roll over in an earthquake, but it's not going to.
It's not going to. We can thank a USC faculty member named Santosh Shahi for suggesting earth anchors as a strategy, and the Walter P. Moore people also came back with sort of the same kind of strategy. Your story about rolling over, absolute nightmares for me, because it's in place now, and it is not. I promised them 100 years. It'll be longer. It's not going anywhere. It's absolutely fixed in place, but during transportation on the truck with a very high center of gravity. The center of gravity is almost at the ceiling line, right? It's really high up. At 60 miles an hour going around a curve on a freeway, we had to work with the Clark Pacific people and a company called Reeve Trucking to do a lot of transportation engineering, anchoring calculations. And we even ended up swapping out the trailer for a slightly wider stance trailer to make sure that as this thing rolled down the freeway and took the curves, that we wouldn't roll it over. It won't roll over now, but thank you, Reeve Trucking, for all of that work doing that. And then Maxim Crane, the people that lifted it off the truck and put it in place, they have the same concern, right? They're picking this thing up from two lift points that are 10 feet apart, but it's 42 feet long. And so lifting up this tube that's not anchored, and it's 2 inches thick. Wait, what? 2 inches thick concrete. I've got to lift it. What am I doing here? And those people were absolutely spectacular. There's a little, 30-second, 1 minute time lapse video of the lift, and you can see dozens and dozens of us all out there in orange vests going, "Oh, please lift it." But the Maxim people were absolute pros. You can see it lasts just 4 seconds in the video. Lift, move, set, down. Good, done.
Nice. One of the things that comes up in prefab and modular is logistics, right? That's where they start the problem is can we actually get it there is where you start a prefab project. And what's interesting to me about this one is that it is a panelized construction, right? But it was done at Clark Pacific and then shipped as one unit. And I'm actually really intrigued to find out that you shipped it in the orientation that it is, with the heavy part on top, because it seems like, wow, like you said, the center of gravity is so high. Could you have just rolled it over? And I could imagine craning it off the truck then becomes a serious problem, right? So all of these logistics, were the students involved in that part of the process as well?
They were. Not every step, right? There were things that were done. Calculating the center of gravity was a student thing, because all we have is a three-dimensional model, right? This 3D model, and we're trying to figure out where's the weight and how do you calculate this thing? So and the curvature, the geometry. How are you going to get a center of gravity? I can do it north-south because it's in the center. I got that. But now what? And so dealing with that was really quite impressive. But these people are pros. The reef trucking people came out and cracked their chin. They came out a few days before we were going to ship it, and so taking a look and how it's being anchored down and all those kinds of things, and did quite a bit of calculation. But there is a picture of me at Joshua Tree when it actually arrived at the park, because I wasn't entirely sure that I wasn't going to be coping with some kind of a, did we break it on the way? It was so
Humpty Dumpty, right?
And then the geometry was the software tools we had in the beginning, and the students. The geometry was designed for trucking geometry, right? That 12-foot thing that I kept mentioning about the size of the thing. 12 foot is the dimension where you cross over and get new rules for transporting. So we're a wide load, but we're not triggering the extra rules that come when you're over 12 feet. We're 40,000 pounds.
It's not an easy drive to get from Fontana to Joshua Tree. You have to go over a couple passes. There's the wind out there when you go through Morongo to get to the 62 highway that actually leads up north to Joshua Tree. So there's more than just the size limitation of the lane that the truck is on and not triggering that next size up. There's all of these other additional constraints when you start moving something this big.
Exactly. Are there going to be any trees or street lights in the way? The object is fairly tall. It's taller than 12 feet because of the double curve. So we used a special trailer that has the wide stance I already mentioned, but also has a sometimes called a double drop. The floor of the trailer is only about 18 inches off of the road surface. That gives you that extra height that you need to make sure you're not going to have issues with anything along the way. We don't have to move traffic lights or signs or anything at all like that. We did have a chase car, right? That's a, routine part. And it was a pretty typical wide load delivery. And then, of course, I asked them to deliver this gigantic thing on a huge semi truck down a dirt road in the middle of a hidden spot in Joshua Tree National Park. I'm sure the driver looking at me like, wait, what are you having me do here? Well, over there, please. No hesitation at all, right? So they're dealing with professionals is a nice thing. They know their stuff.
And I have to ask you the famous quote: "How much does your building weigh, Mr. Foster?"
I am a huge fan. I actually attended at Cal Poly a lecture by Buckminster Fuller, and the quote he used there was, "To how many decimal places does nature calculate the value of pi to make a bubble in the ocean?"
Oh, wow.
I was like, oh, geez. But he's even more famous for exactly what you described. How much does your building weigh? I can tell you, we know pretty close. We were not able to weigh it, but we know that we're pretty close to 40,000 pounds, plus or minus a little bit because of, things. But we know how many bags of the ultra performance mix was in there, how many bags of the steel fibers were in there, what all the connectors are, all those kinds of things. We know the geometry. So I could be off by hundreds, but not thousands. It's a 40,000 pound object. To me, that's really heavy. To the trucking people, it's routine.
No big deal. It's interesting to me just because the tools now allow us to, in an easier fashion than it ever has been before, to do things like that, to understand things like that. And I think for a student to understand the effect something has on the built environment in so many different ways through analysis and environmental analysis and through, like even in a national park where it's common practice to leave no trace and to think about the way these things are anchored. And there's just so much potential in this process that you have gone through in your courses with these students to really connect them to place and to connect them to architecture much more than the profession actually enables young professionals to do, because you're sitting at a desk operating a computer and software, right? Rarely are they out on site. Rarely are they visiting the thing that gets built, even during the construction process, maybe afterward, because they're just curious and they want to go see it and it's open and they can, right? But this is a phenomenal shift, I think. And it's something that I would expect that students would just become like, kind of like what you experienced during the course. That this is just normal. Like, this is the course I signed up for. But I do think those expectations are going to translate into the practice itself, and the expectation of having these hands-on experiences and knowing how buildings affect culture and how they affect the people that use those buildings in the environments and the places where they're situated. I think all of that's very positive for the profession.
I think you're absolutely right. And having our condition was a little bit unique because we had a graduate student working on this software tool, but having the students be able to, live while they're adjusting the design, they're playing the parametrics, they can see how much concrete they're using, right? More or less exactly. If you pull on this piece to make it a little bit larger, that affects all 5 panels and the mold, right? If you can't make the wall thicker there without making the foundation thicker and the roof thicker, right? And so and these edges had to match. Some of the conditions where these really unusual curves, you'll see them out there. They're sort of twisting 3-dimensionally in space. We started to give them names. There's one called the Mackey curve. Mackey Lopez was in the class. He was responsible for dealing with how the Mackey curve in the wall, as it comes up and twists, has to meet the roof panel as it's twisting, coming back at it. And these are going to be cast on the opposite sides of the mold. And come on, Mackey, I need it. I need it. We got to figure this out. And it's absolutely glorious when you go out there and you see how these things line up. It's mind numbing that we're casting. I think because this ultra high performance concrete is not like regular concrete. We got a curved mold. You can't just pour the concrete in and look at it. If you just poured it on this curved mold, it would all just flow off onto the deck and onto the ground. So the object had a bottom mold with sides and a top mold, and we cast it blind. We poured ultra high performance concrete into a little funnel at the top until it filled up the funnel. And then tomorrow you can come back and see what you got. The joy of opening up it's a surprise package, right? We poured this weird mix concrete, it's a very strange pour. It doesn't look like concrete at all. We poured this weird mix into this hole, and I don't know if we told people it's pink because we did some color calibrated studies with a little tool out there on the site. And of course, in any natural environment, you'll come up with all kinds of colors that actually match. But we did a lot of studies, and it's a beautiful shade of very pale pink that just looks like it belongs. It's absolutely beautifully done. So you're pouring this pink material into the top of this mold and then go home. We'll see you tomorrow when you come back, and we'll pull it out of that.
There's just so many things that students are forced to think of in a process like that that even everyday architects don't have to think about on most of their projects. So I think that is just an amazing experience for them to have. And this has been enabled through collaboration and technology and your passion to bring these things together and to see it through to the end. All of this is just really commendable. And I'm really happy we got to have this conversation about it today.
It's been quite enjoyable talking with you. I have more secrets to tell, but we'll tell them over time, and maybe people can come out to see it once we have our open house in December.
Absolutely. So talk about that maybe we'll finish with that. What are the dates? If anybody is in Southern California and is willing to visit Joshua Tree in December, which is a fantastic time of year to visit Joshua Tree. I actually have photos from December 27th, 2019 of 6 inches of snow in Joshua Tree. And it's absolutely gorgeous. So hopefully there's no snow at this point, because it actually just makes it harder to get there. But give everybody the date and of the open house and how they can see this in person.
So we're going to go out there on December 11th. There's a sign up and registration process because the site is big enough, but we need to know what we're facing in terms of people coming. The dirt road going into the site is a one-lane road. And by one lane, I mean one lane. So we have to do who's leaving and who's arriving coordination. You can't go both ways on this little road. The location is a campground that is not on the map. This is a campground that will be it's a future campground. It's just getting started. And it's called a VIP campground. VIP does not mean very important people. It means volunteers in parks. The National Park Service has volunteers that come out and camp in the park and work all day, right? They're fixing trails, doing signage, they're doing all kinds of things. So if you're a National Park fan, you need to be a VIP and get out there and help out. But this is a VIP campground that's really just getting started. It's got a few picnic tables, not much else at it. And so over time in the coming years, more and more will be added to make it like a real campground, but it'll probably never be a public campground. It won't be on the map. So it's not illegal to go there, but you have to know to go there, right? The Park Service doesn't mind. You're allowed, but you can't go camping there. It's a VIP, Volunteers in Parks campsite. So we'll go out there on December 11th in the afternoon and have a little event. And then if people want to know how to register, how do we have them do that? They can email me. There will be a website that has that. Can we append it onto the end of this?
Absolutely. Yeah, we can put it in the show notes where there can be a live link. Once that link is available, we can add that in, and whoever's listening before that date can click on that link.
Yeah. So guests are welcome, but surprise guests aren't, right? We got to know what we're facing.
You need to know ahead of time. RSVP only. So Doug, what is your email address, or what are you willing to share on the podcast so people can find out more? I will obviously include links to the things we've talked about today, but just to contact you, I just can't understate it enough before you give that information, how much help you're doing to create great architects by sharing stories like these that attract people to architecture school who want to do projects like this in the future. And so I just want to thank you for that and acknowledge that of you, because I'm always impressed by your passion and your tenacity to continue to tell these stories.
Well, I'm grateful for the very kind words. I will tell you that my career is absolutely spectacular. I'm enjoying every minute of it, and they pay me too. Not a lot, but they do pay me to do this.
Right.
It is an absolutely spectacular career. People who talk about kids in college these days and say, yeah, kids these days, yeah, I'll take any 12 of mine up against any year you want to say from the past. What these people can do is mind-numbing. And so, college kids. So my email is easy. It's my first initial and last name, so dnoble, DNOBLE, at USC.edu. And you can also learn a lot. There are 4 or 5 videos online in YouTube. If you put Carapace Pavilion or Carapace Pavilion USC or Carapace Pavilion Joshua Tree, you'll find these videos, including the time-lapse install video is up there. It's 60 seconds long, I think, or something like that. But people are welcome to email me or be in touch. And then I have all kinds of pictures up on, if you're a Instagram, Facebook, LinkedIn kind of a person, again, hunting Doug Noble or Doug Noble Carapace or something like that, we'll find all those things.
Perfect. Doing the things that most instructors don't do. Doug, this has been an amazing conversation. And again, thank you for having it with us today. And I'll talk to you soon.
Very good. Thank you for having me here.
Thank you to Avail for their support of this podcast episode. Visit getavail.com to see their holistic approach to content management today. This show is part of the Gabled Media Podcast Network. You can see all the shows at gabledmedia.com. That's GABLMEDIA.com. You can help support what I'm doing here by leaving a 5-star review on Apple Podcasts to help get the word out, and of course, share it with your friends. I'd love to hear from you, so leave a comment on the website at trxl.co/podcast, where you can find every episode. You can also follow me on Twitter and Instagram and YouTube. Just search for E. Troxel. Talk to you soon.